Good evening, Dalvi.
Students able to interact with me, ma'am?
Yes, sir, they could interact.
Okay, ma'am. That access is given to the students, it will be okay, ma'am. Because today I am trying to do some demonstration with the codings. If they can able to unmute themselves and then they can interact with me, then it will.
We'll make it, sir, no problem. Access is given, sir.
Good evening, dear participants, and a very special good evening to Dalvin, the hero of this workshop. Welcome, Dalvin. Welcome back, all the participants, for this second day of this training program. Let us commence this workshop with a word of prayer. Let us close our eyes and look up to God for a few minutes. Let invite God's presence for this workshop. Let us pray. Our loving, gracious Heavenly Father, we thank you for this blessed evening. Lord, we thank you for all the blessings that you have bestowed in our life. Lord, we thank you for all the protection, your blessings, your guidance, the love, the care, the affection, whatever you bestowed in our life for our protection. Thank you, Lord. We surrender ourselves in your mighty hand. Especially, Lord, we thank you for this workshop, this training program. As we are going to start the second day of this workshop, Lord, we beg your presence to be with us. We need your guidance. We ask your presence to be filled with our resource person, Dr. Dalvin. Lord, give your words. Let this workshop, let this training program be a useful, a blessing for all the participants, those who are all connected through this Zoom app. Once again, we commit ourselves into your mighty hand. Especially, we commit the entire session into your mighty hand, Lord. Especially, fill the resource person with your knowledge. We thank and we praise, we give glory and honor to you. We pray through our Lord and Savior Jesus Christ. Amen. So now I just request our Professor Dr. Gayatri ma'am to propose a formal welcome address for this second day of training program.
Thank you, sir. I thank Almighty for this wonderful event to happen thankful to the administration for their generous support to have all these sorts of training program to all the research scholars, academicians and other people. Very glad to have Dr. Dalvin sir in our midst. Thank you, sir. And we can start, sir. Yes, sir. Thank you so much, sir.
Thank you, ma'am. Thank you so much. Dear participants, especially you had a wonderful session.
Feedback.
I hope now, without taking much time, I'm just hand over for Dr. Dalvin. Dalvin, take your time.
Yeah, sir. Thank you. Thank you, sir. Can you able to see my screen, sir?
Yes, Dalvin.
Right. Participants, very good evening. So I hope you people enjoyed yesterday's session, and today you are eager to there to learn about how to develop this IoT application, right? So before starting today's session, so we will have a small summary about the yesterday's session, what we have seen, right? So yesterday we have seen the small introduction about the IoT, and then few of the IoT applications we have discussed, and then to develop these IoT applications, what we need to do, right? So, so as we discussed yesterday, so we need two things to convert this thing into a smart thing. Right? The ordinary things are converted into smart things by adding two things, right? So one is computing part and the other one is communicating part. So now to add this computing, right? To add this computing, we need to write the code. So where we are going to upload the code? So in the embedded technology, that is the processor boards, right? So we are choosing the hardware. Now the programming that we are going to use is the board which we are going to use is Node MCU, right? Right. So today we will see how to code, right? How to do the coding for this embedded board, the processor board. So we will explore this coding, right? We will right?
And சும்மா இது workshop மாதிரி.
Right. So now I want you people, I want any one of the students to unmute yourself. I want any one of the students. Yes, Sangeeta, can you unmute yourself? Yes, Sangeeta, Siddharth, Prem, you people can unmute yourself.
Sir.
Yes, is this Siddharth?
Yes, sir.
Yes. Good evening, Siddharth. How are you?
I'm fine, sir. How are you?
Yeah, great. Right, Siddharth. Have you installed this Arduino IDE?
No, sir.
Okay,
I haven't.
No issues. If you didn't install, so follow the procedures, right? Follow the procedure to install. So now what you people can do, if you didn't install Arduino IDE, no, don't worry, right? Just if you are working with your PC, just open a Word file or a notepad, right? Going to this Zoom. If you are attending the session through your mobile, just take a pen and paper, right? So it will be helpful for you to do the exercise which we are going to explore today. Okay. Then Siddharth.
Yes, sir.
Yeah. So can you able to tell me any one of the things that you want to convert as a smart thing? Which thing in this world or which thing around you want to convert as a smart thing?
Not anything new, sir. It's already everything is nowadays it is going on IoT, I think so. Everything is getting automated right now, and in my point of view, if we use, I would think about my room itself, sir, because voice recognition is playing a vital role nowadays, sir. And voice recognition, what we are saying will be converted into work, and it will work like that.
Right. Okay. Good. So the same question which I asked in some other college. So one of the students replied like this: "Sir, I want to convert my pen. Right? I want to convert my pen which I am writing into smart pen, sir." Then I was wondering, why you want to convert your pen into smart? Can you able to tell one application for that? Then he said, so whenever I am entering into the exam hall, If I'm scanning the question paper, the pen need to give the answers for me. See, that is what they are thinking. See, right? So the whatever the things, yeah, it is possible, right? So whatever the things which is surrounded by us, that we need to convert into smart, right? So today we will explore, right, how to code a hardware using Arduino IDE, right? Right. To code, right, to program into the Arduino IDE, right, the main part that you need is you need one hardware, right? And then the next thing is you need the Arduino IDE software, right? So I hope few people will be having these two essential requirements, right? So if you have these two essential requirements, and then additionally you need to include the library for Node MCU board. Why we are adding this Node MCU library board additionally? Why? Because this Arduino is the software which supports only for the Arduino hardware, whereas Node MCU is not belongs to the Arduino company. So we are installing the additional library, right? So that is one of the strength of this open source software and hardware, right? So now we are importing the libraries of Arduino, and then we are importing the libraries of Node MCU, right? So now all your setup is ready, right? So once your setup is ready, right? So first thing before coding, what you need to do, right? First thing in the Arduino IDE, you need to select the type of the hardware that you are going to code, right? That is the very first thing when you are opened the IDE, that is the software environment, you need to choose the type of the hardware that you are going to code, right? Again, after choosing the type of the hardware, right? Again, you need to choose the communication port, right? Again, what is the communication port, sir? Again, a question comes, right? See now, how we are going to connect the board. So this is, let's say, this is my hardware, right? So now this is my hardware. So I'm going to connect this hardware using the USB cable, right? So now this USB cable is connected to my system. So now I'm plugging this hardware. So now my hardware is connected to my computer, right? So through the data cable. So using this, I'm going to code this board. Then using this, I'm going to code this board, right? So now you imagine I have connected two or more boards in my computer. Right? I have connected two or more boards to my computer. It's simple. You imagine like this. You have connected two pen drives, right? Two pen drives to your computer, right? You want to copy some data from your computer to your pen drive, right? Ultimately, what you will do, you need to choose which pen drive you need to copy the data, paste the data. Can you get my point? See, for example, E drive and F drive. E drive is one pen drive, F drive is another pen drive. If you want to copy the files in E disk, that is E drive, you need to open the E drive, there you need to paste. The same way, if two or more number of ports are connected to your computer, which board you need to code. So that one, here we are choosing using the port. Can you get my point? So this communication port will be activated 2, 3, 4, 5 based on your computer requirement. It will be right named as communication port 3, communication port 4, communication port 5. Right? So which communication port the board is attached, that one you need to choose. Right? Students, first what we need to choose, you need to choose the type of the board, right? So in our case, what type we need to choose? We need to choose Node MCU, right? Node MCU is the type of the board we need to choose. And then the second one, we need to choose the port. What is port here? The port is the board where it is connected, right? And then the next one, the next thing that you need to do is the coding part, right? So in Embed C, right? In Embed C, while coding, right? So these are the two functions. These are the two functions are mandatory whenever you want to code a hardware, right? So using this Embed C, these are the two. As like C in C, which is the mandatory function? Void main. Right? Without void main, you can't be able to execute the C program. Right? The same way in Embedded C, these two are the essential methods, essential functions. Without these functions, you can't be able to run or you can't be able to execute. Right? So whenever the code is executed, these are the two mandatory functions executed at first, right? So one is void setup and the other one is void loop, right? As the name indicates, void setup is the function which is going to have all the settings. Settings means what? See, yesterday I said, so this board having many different pins. So that pins can be used for input as well as output. Can you get my point? So now you need to tell the system that I'm going to use this pin as an input. You need to educate the system, I'm going to use this pin as an output. Can you get my point? So you need to initialize the pin, whether it is an input pin or output pin, right? So those initialization need to be taken place in this setup, right? Inside this setup method. Again, in the void loop method, see the name indicates it is a looping method. Whatever the code you are giving inside this loop method, it will continuously execute. Right? Continuously execute. Till when it will execute? So there is no ending. It is an loop. Right? It is an unlimited loop. So it will run unlimited, infinite loop. So there you can give the delay. 1 hour once the loop need to run. See, there you can give the delay. Then the code will run. Then again it will wait for 1 hour. Again it will run. Again it will wait for 1 hour. Again you can give 1 minute. Again you can give 1 second. Again you can give 1 millisecond. 1 millisecond once this code can be executed. Likewise, you can give the delay. Based on the delay, the code will be executed. Right? So these are the two essential methods. Again, after doing, so now I have initialized, now I have did the coding, then what you need to do, right? The third step that you want to do is you need to compile and upload, right? So this compile and upload are two. So you can carry out this compile and upload. Whenever you are uploading, right? Whenever you are uploading, the code will be compiled. If there is any error, right? If there is any error, it will throw the error. If there is no error, then automatically the code will be uploaded. Where the code will be uploaded? So here, we are choosing the port, right? So to which port we are choosing? The hardware which is connected to that port, the code, whatever the code that you are giving here, it will be uploaded, right? So once it is uploaded, right? Once it is uploaded, the hardware will continuously, whenever the hardware is powered, the hardware is continuously running the code. Then that time the board is not necessary to connect to the Arduino IDE. Once you have uploaded the code, you can remove the hardware from your computer and then just give the power to this hardware. The code will automatically run inside the hardware, right? So these are the three essential steps, right? These are the three essential steps you need to follow whenever you are coding a hardware using Arduino IDE. Very first step is you need to select the board type. Which board you need to choose, right? Again, you need to select the port to which port the board is connected, right? And then the second step is you need to do the coding. Whatever the coding you want to do, you need to code. And then the third final step is you need to compile and upload the code to the hardware, right? Right. Shivakumar C. Shivakumar, can you unmute yourself? Shivakumar, can you able to hear me? Shivakumar? Satish? Or Pushpu Joshi? Can anyone unmute yourself? Ramesh, Arvind, Revati. Ramesh, can you able to hear me?
இதைத் தொடர்ந்து கடந்த திங்கட்கிழமை ஜெயம்
Ramesh, Kushbu, anyone, you can unmute yourself. Sure. Sure. Siddharth,
Sir,
Siddharth, can you able to understand what is this 3 steps that you want to follow before coding this environment?
yes, sir.
Okay, okay. Right. So this selecting the port and choosing the board, coding environment, and then compiling. Right. Okay.
Yes, sir.
Then Shiva Shankari G. Shiva Shankari. So now we will see one example program, right? We will see one example program, and then we will. Right. So now let me take a default LED, right? Default LED which is present in this hardware, right? So this default LED which is present in this hardware, now I am going to on this LED, right? Again, I am going to off that LED, right? So now what I am going to do, I am going to turn on and turn off the LED which is present in the hardware. Okay, so now if you want to on or off the LED, right? So that pin, whether you need to use as an input pin or output pin, right? We are going to switch on the light, right? So here it is an output, right? So we are using the output. So here in the setup part, right? In the setup part, we need to mention the pin name and the pin mode, right? So here you can see pin mode. See again, pin mode is the function, right? Pin mode is a function. So here pin mode is a function. See, we are not defining this function anywhere else, right? Yesterday I have said, so we are not going to define or we are not going to create any function, just we are going to use the function, right? So here you want to mention the mode of the pin, you need to give the pin name as the parameter 1, and then the mode, whether it is an input mode or output mode, as the second parameter, right? So here what is the pin I am going to use? LED built-in, right? So LED built-in is the pin, right? LED built-in is the pin, and then I'm going to use that pin as an output pin. Students can able to understand. So that is what I'm going to give in the setup part. Right, that is what I'm going to give in the setup part. Right. Again, I am coming to the loop part. Right. So now in the loop part, to turn on the light, right? To turn on the light, the function which we are going to use is digital write. Right. Digital write is the function we are going to use for turn on or turn off an electronic equipment, right? Or to turn on or turn off a pin, we are going to use the function digital write, right? Digital write. So here inside the parameters, right? Inside the parentheses, you need to give the pin name. What is the pin name? And then here the status, right? Here high indicates on, right? Again, low indicates off. So digital write LED built-in high. which indicates the pin, LED built-in pin should on. That is digital write. Right? Can you get my point? So now what I am going to give, I am going to give the delay. So here delay is what? So how long the light need to on? So here, whenever you are using the delay function, see again delay is the function. So inside this you are using the parameter. So 1000. So whenever you are using the delay function, the parameter which you are giving inside this delay function, always it is in milliseconds. Right? So here this 1000 indicates 1000 milliseconds delay. 1000 milliseconds in the sense 1 second. Right? So if you want to have more delay, you can increase the delay over here. After 1 second delay, I want to turn off the light, right? I want to turn off the light. That is digital right LED built-in low. Right now the light is turned off. Now the light is turned off, right? So how long the light need to turn off? So again I am giving the delay as 1 second. So now this loop will be executed. See, first this line will be executed, the light will on for 1 second. Again after 1 second this line will be executed, the light will off. After 1 second, again the loop will come here. This line will be executed. This line. Again the loop. This loop will be continuously executing. Okay. So now this setup part will execute once, whereas this loop part continuously it will execute. Right. So now we will see this same program in the programming. Right. So now can you able to see in my screen? So this is the whenever you are opening, see this is the Arduino IDE, right? So in this IDE, I am clicking file and then opening the new, right? Whenever you are opening new, right? So here the program, whatever we are doing, right? The program, whatever we are doing, here we call it as sketch. Right? So in .NET environment, what we will do, what we will use the program name as a project, right? Project 1, unknown project 1, that is the default name, right? So we call it as project. Whereas in C, what we will tell the unknown .cpp, unknown2.cpp, right? So here we call the program as sketch, right? So by default, the name for your program will be sketch underscore the month and date, right? So today, this is January month and today's date is 12. So what does this B indicates? Already I have created a program that is sketch Jan, that is A, then Jan 12B, Jan 12C. Likewise, the name, by default name it will be there. You can save in whatever the name you want, right? So whenever you are opening, right? Whenever you are opening this one, see by default, this setup function and loop function, it will be there. Whenever you are opening a new sketch, right? This setup and loop automatically it will be there, right? So you can be able to see. Okay, so you need to initialize the pin over here, and then you need to code it, right? So as I said before, very first thing what you need to do before coding or before coding an environment, right? So what is the very first thing you need to do? We need to check the type of the board what we are going to code, right? So here what you need to do, you need to check the type of the board. So today what board we are going to code? So we are going to code this Node MCU board, right? So that one you need to choose, right? So here in the tools you can able to see in the top menu, file, edit, sketch, tools and help. So here in the tools, right here in the tools, you can able to see the board menu, right? In the board menu, you need to come and you need to choose the Node MCU, right? So now I have chosen the Node MCU board. See here you can see the Node MCU board is chosen. Board, double quotes, Node MCU, right? So I have chosen the board now, right? So now I am going to code Node MCU board. Again, you need to choose the port. See down here you can able to see the port, right? So now you can able to connect the board and then you can see the port which is going to be enabled. So in my case, see here, the port is not enabled, right? So why the port is not enabled? So if the port is not enabled, it means that your board is not connected properly, right? Your board is not connected properly. If your board is connected, right? If your board is connected, then the port here, whatever the port that is coming here, it will be enabled, right? 1 second, I will connect my board. So in the tools, see now you can able to see the port is enabled, right? So now I have connected the board and then the port is enabled. See here, COM port 5, right? So now I am choosing the port. See, after choosing the port, here you can see port in the double quotes port number, which port we are coding, right? So now we have chosen the board type and then we have chosen the port number. These are the primary things whenever you are entering into the IDE that you need to do, right? So after that, so I have done the code. See here in the setup part, I am using pin number 2, right? And then I am on the pin 2 and then delay, then turn off, right? So now coding part is over. The very next part is compiling and uploading the code, right? See here in the sketch, right? In the sketch menu, you can able to see verify/compile, right? Verify/compile and upload. So you can use the shortcut key Control+R or Control+U, the shortcut keys from your keyboard, or else see here, can you able to see that these two menus, one tick symbol in the Arduino IDE in the top, again here you can see one arrow mark. So these two are the buttons which is used for compile and upload. So this tick mark is used to verify and compile, this arrow mark is used for uploading the code, right? So now I am compiling my code, right? So you can able to see in the bottom of my screen, the sketch is compiling. Again here you can able to see the taskbar, right? So here it is the status. So what is the status? How much it is compiled, right? So green color symbol which is indicates, right? So once the compiling is done, so here you can see one black color window. It is bottom of the Arduino IDE. So here you can see the output for this program. Whatever the code, see whatever the code it is coming, the output here you can see. See, can you able to see here? So now done compiling. The compiling is done. So there is no errors. There is no errors. And it is giving, see here it is giving the status of the code. The sketch uses so these many bytes of the program storage space. This is the maximum memory of this board, right? Again, in that memory, this many bytes are dynamic memory and these many memory are the local variable memory. So this is the maximum space that you can use. So that is the status of this hardware. Once the compilation is over, this will be done, right? So now the code is ready for upload, right? After that, you need to give upload button to upload the code, right? So now I am uploading the code. See here, it will come uploading, right? That is the status. So here you can see the percentage that the code is uploading, 41%, 50%. Likewise, the code will be uploaded to your board. At that time, you are not supposed to remove the board from the data table, right? So once the code is uploaded, right? Once the code is uploaded, here it will come done uploading, right? So once it is uploaded, you can able to see the light which is in the LED that is blinking. See, 1 second on, again 1 second off, 1 second on and 1 second off. right? So continuously it will run. So after this, what you can do? You can remove the board from this hardware, right? That is from your software, that is from your computer, and then just you give the power to this board. The code will automatically run, right? So now what you can do? So now what I am going to do? I am going to increase the delay for on, right? See, now instead of 1000, I am giving it as 3000 so that you can see the difference. See now, on and off both are equal, right? On and off both are equal. So now directly I am going to upload. Why I am directly going to upload? Because already I have chosen the board type, already I have chosen the port. So now I am directly going to upload. See, previous program I have compiled and upload, right? So now I am clicking directly upload, right? Have you noticed here? First it will compile and then only it will upload. Whenever you are clicking the upload button, first the code will be compiled, right? If there is any error, then it will throw the error. If there is no error, then automatically it will skip for uploading, right? So no error, the program is uploaded. So now you can able to see 1 second on, 3 second off. Can you able to see the delay, right? So now the light is only 1 second on, the remaining 3 seconds it is off, right? So likewise, you can increase and decrease the delay, right? So now what I am going to do, I am going to reverse, right? So now the light need to on for 1 second and then on for 3 seconds and then off for, right? So again I am giving upload, right? So whenever I am giving upload, the code will be uploaded. The code is uploading here. Let's see the output. So once it is uploaded, here you can able to see the. So now you can able to see 3 seconds the light is on and then 1 second the light is off, right? Any doubt in this programming? Anyone having any doubt? So if you have any doubt, you can raise your hand, right? Students, don't hesitate, right? So here I am here to help you out, right? So if you have any doubt, if you didn't understand any of the programming part in this code, right? So raise your hand. I will tell you, I will explain you again, right? So if you didn't understand this part, right? So you can't be able to follow the whole workshop. That is this 2 days workshop, you can't be able to follow, right? So if you have any doubt, you can revert me back. All right. So I hope everyone have understood this. No doubt in the class. Great. Someone has unmuted. Right. So now we have seen the basic coding, right? So basic coding for uploading, right? So how to upload the code, right? So the next example program that we are going to see is, right? So now see, we have coded in the IDE, right? Arduino IDE environment. After coding, where we are seeing the output? We are seeing the output in the hardware. Students can able to understand. So we have coded in the Arduino IDE environment in my computer, right? I am seeing the output for that program in the hardware which I am connected, right? So sometimes, right? Sometimes, see now I have coded this one, right? After that I am connecting to this. Right? I don't know what code is uploaded in this book, right? So now if you have observed, you can see 3 times I have uploaded the code. 3 times I have uploaded the same code with a few modifications, right? So whenever I am uploading, in between I didn't erase the code which is uploaded in this board. Instead I have uploaded. So what it will happen, whenever you are uploading a new code, the code which is already there in the board, it will be rewritten, right? It will be overwritten. Whatever the code already there, it will be overwritten in the code, right? So instead If it is deleting the whole code, it will be overwriting. Overwriting in the sense, see for example, there are two pins you are used in this code, right? So pin 1 and pin 2. If you are changing pin 1 alone, right? In the second program, you are not using the pin 2. Right, even though you are not using the pin 2, the code which is written in the previous program for the pin 2, it will be already exist in the board. So the code will be rewritten, right? So there is an option to erase all the code in the board also, that is flashing. So here in the board you can able to see reset and flash, two buttons in the right and left side. So this reset button which indicates to reset the program. Whenever we are restarting, from the beginning the program is going to be executed. Whereas this flashing is used to erase the code which is uploaded in this board. If you want to erase the code, just continuously press this flash button for 2 to 3 seconds, then automatically the code which is inside this board, it will be deleted automatically. Can you able to understand? Right. So now what we are going to do, we are going to print some output statements. And then we are going to see in the system itself. Right? System itself in the sense, so this board is going to throw some output that is going to be printed. So where it will be printed, sir? Right? So in Arduino environment, for printing, right, in the Arduino environment, for printing, it is used as serial monitor, right? So serial monitor is there to see the output. Serial plotter is there to see the output. Serial monitor, serial plotter. What is this serial monitor and serial plotter? So this, which is the additional screen where you can see the output of your hardware, right? So where you can see the serial monitor in these tools, here you can see serial monitor. If you click the serial monitor, a new window will open. Again, serial plotter. So this plotter usually it will use for visualizing the output in the graphical method, line graph, path graph, any one graph it will be moving, right? Or else in the right hand side corner, here you can see one search button. Right, search button like, right? So if you click this, the serial monitor will open. Either you can go to the tools and then here you can open, or else in the right hand side button you need to open, right? So if I am clicking the serial monitor, right? See? Can we able to see? So this is the serial monitor, right? So here you can see the output. Able to hear, right? So now whatever the output you want to see here, you can see. See, as like other programming languages, we are using what we are using. We are using the printf statements, right? Printf statements. So that will be printing. See, those who have already experience in Arduino programming, those who at Android programming, right? So while developing an Android activity, right? So you will be seeing the output in the emulator, right? You will be seeing the output in the emulator, right? We are not seeing the output in the programming environment. If you want to see the output in the programming environment, there we will be using log messages, right? Log messages. So that log messages, what it will do, it will give the output in the programming environment itself, right? So that log message, same like the log messages, here we are using this serial monitor to print the message in the programming environment itself, right? So now what I am going to do is, whenever the light is on, I am going to print a statement that the light is on, right? For printing that, what we are going to use, we are going to use the serial print function, right? Again, see, I am using the serial dot print function. See here, serial dot print ln. So what is serial dot print ln? See, you can use serial dot print alone. So you can easily identify what is serial dot print and what is serial dot print ln. So ln which indicates the next line, right? So in the serial dot print ln, right? Serial dot print ln function, whatever the text you are giving here, whatever the text that you are giving here, it will be printed as it is. So here I am giving hello, so then it will be print hello, right? Can you get my point? So again, so in the setup part, what we need to do, which is one of the important things, serial dot begin. So what is the serial dot begin? So here in the serial dot begin, we are turning on the serial monitor. Whenever this line is executed, we are turning on the serial monitor. Right? Again, one complication comes. So now I have connected two or more boards to my computer. Right? So now these for example 4 boards I have connected. All the 4 boards will give some message to the serial monitor. So now which board need to communicate to which serial monitor, that you need to indicate here. So that we call it as baud rate. Right, that we called as baud rate. So here I am using the baud rate 11500. Right. Other than this, many other baud rates are there. 9600 baud rate is there. 125691 is there. Right. So most of the programs will be using 9600 and then 11500. These are the two baud rates that we are frequently using. Right. So now you need to choose the baud rate and then you need to activate the serial monitor. Right. So now we will see how this code is executing. Right. So just so now what I have did, I have added a serial printed line after this on, right? So what is the line indicates? Light on. Again, the light is off, right? So now what I am going to do is I am going to upload the code. So just I am uploading the code, right? So now the code will be uploading here. Student, here you can able to see the functions and the default functions are in pin orange color. That is the pin mode, serial begin. These are all in orange color, right? Again, the keywords which are in blue color, right? So if there is any error in the program, then automatically the code here you can see the color change. It will be black. So if it is a default function pin mode, then it will be in the orange color. Again, if you see, it is case sensitive. See? Here also I have given pin mode. So even it is not coming in color. Why? Because the M should be in capital, right? Uppercase. So now I have uploaded this code. So here you can able to see the light is on and off, off, one second, then again on and off, right? So now I am going to open the serial monitor, right? So where this statement is printed, right? So here you can able to see this is a serial monitor. So we have printed, what we have printed? Light is on, light is off. That was we have printed. See here, some other values are coming. Why? Because in the serial monitor, which baud rate we have coded? See here, 11500. So here you need to choose the baud rate. 115200. So if you choose this baud rate, right? If you choose this baud rate, after that, if you reset, right? If you reset the board, so once the board is resetted, right? So here the program will come again, and then here you can able to see whatever the baud rate, whatever the function that is there, then it will be printed in that baud rate, right? So here, whatever the baud rate that you are giving, right? The same baud rate that you need to choose in the serial monitor also, right? So the baud rate of the programming, whatever you are giving in the code, and then the baud rate in the serial monitor, both it should be in the same one, right? So that is the major thing whenever we are seeing the output in the bot, whenever we are seeing the output in the serial monitor, right? The serial monitor is nothing. You can print some statements, right? You can print some statements in the serial monitor. Using that one, you can see the output. Right? Here, right? So now you can able to see light is on. Again, light is off. Again, light is on. See, continuously the loop will run. Light is on, light is off. Okay. And able to see the printf statement, whatever we are printing, right? So it will, you can able to see the output in the programming environment itself. Okay. So this is the function, that is the serial.println function, right? So, so we will quickly go and we will quickly discuss about the sensor connectivity, right? So why I have taken this much time for this two program alone means these are the two important functions or the methods that we are going to follow for all the programs that you are going to see, right? So if you people have any doubt till now, you can raise your hand and then you can ask, right? So any doubt? Participants, is anyone having any doubt? Rajeshwari from second MSc. Rajeshwari. Rajeshwari from second MSc. Rajeshwari, can you able to hear me? Rajeshwari, can you able to unmute yourself? Right. So, so students, what you need to do? So you need to code, right? You need to code. See here, in this example, right? In this example, I have coded for one LED, right? One LED on and off, right? So in the same example, right? The same example you take, and then you need to develop for three LEDs, right? Three LEDs on and off, right? So in simply on and off, what you can do? You can take the traffic signal, right? You can take the traffic signal, right? So how long the red light need to on? Again, after red light, which traffic light need to on? After the yellow traffic light, green light need to on. How long this on? And then how long that light should be off, right? This one traffic, right? One traffic signal light, you can code and come. You need to code and come tomorrow, right? All right. So we will see one sensor connectivity, right, to the board, right? So now, if you want to connect a sensor to the board, right? So why we are connecting a sensor? Obviously to get the values. See, for example, if you are connecting the temperature sensor to the board, right? So you can able to get the values from the sensor, right? So now before before seeing or before discussing the sensor connectivity, you people need to have the basic knowledge about the sensors, right? So the sensors available, right? The sensors which is available in this market, right, are categorized into two types. They categorized into two types. One is analog sensors and the other one is digital sensors. Analog sensors and digital sensors, right? So obviously analog sensors are going to give the analog values, digital sensors are going to give the digital values, right? So no worries, right? So the next classification of these sensors are active and passive sensors, right? Active and passive sensors. So what is the difference between this active and passive sensors? So here, this active and passive sensors, see these passive sensors, right? What it will do, it won't give any value, it won't give any value unless until you request or unless until you do the action. Whereas these active sensors, you no need to give any command. Continuously, it will sense and it will give the value. Continuously, it will sense and it will give the value. See, for example, if you are using a temperature sensor, it is an active sensor, right? So continuously, what it will do, it will sense the value, it will sense the environment, and then it will give the temperature. Whereas if you take the IR sensor, right? This IR having two. One is sender and another is a receiver. Transmitter and the receiver. The transmit need to transmit the light. The same light need to be reflected and received by the receiver. So this is passive type. So unless until the transmitter transmitting the IR waves, the receiver, it won't work. Can you get my point? Right? So this passive types, few of the sensors were there. This IR sensor, again this ultrasonic sensor. These sensors are all passive sensors. See, this is a transmitter and this is a receiver. If the transmitter transmitting the ultrasound waves, then only this receiver can receive. If the transmitter is not transmitting, then this receiver can't able to receive. Whereas, so this is the gas sensor which I am having. So this is an active sensor. Here, no transmitting, nothing. Directly it is going to give the right. So now, before connecting this sensor, right? So whatever the electronic equipment, whatever the electronic gadgets that you want to connect, the primary thing what you need to do, you need to power that sensor, right? You need to power the sensor. So you need to connect, right? So you need to connect. So the for powering this sensor, right? So more all the sensors, right? All the sensors it are coming with the DC power supply, right? DC power supply, right? So the power which we are using in our home, that is alternative power, right? Alternative power. So here, for example, these are the two pins. You can plug into the plug like this. Again, you can revert to this and then you can plug in like this, right? So no worries. Plus and minus can be inverted in alternative current. Whereas in DC current, positive need to be connected with positive, negative need to be connected with negative, right? Positive need to connected with positive, negative need to be connected with negative. That is the objective or that is the main rule of DC connectivity, right? So now the sensor that we are going to use, that is an DC voltage, right? So now most of the sensors will be having three pins, right? So what are all those three pins? Let us imagine this is a sensor. So it is having three pins: VCC, ground, and output, right? So VCC, which is positive, ground, which is negative, right? So positive and negative. These two are what pins? Power pins, right? Again, this output, what pin it is? It is the data pin, right? So now this power pins can be connected to the board to the power pins. Again, the data pin need to be connected to any one of the data pin, right? So now let us see the connectivity. So now this positive, that is VCC, need to connect to the positive. So now this VCC need to connect to positive, right? So in the node MCU board, in 4 places you can see the power pins. See here, V in and the ground, right? Again, see here, 3V3 or else 3.3V, right? Again, here you can see 3.3V. Here you can see 3.3V. So these are all power pins. See, the color indicates, red color indicates positive, black color indicates negative. So in the board, you can't be able to see any color combination. Instead, in the board here, you can able to see the letter which is giving. Here you can able to see the letters, right? So in the board, you can see the letters. Here you can see the letters. See, here in the picture, you can able to see A0, G, right? So likewise, the letters it will be there. So here you can able to see 3V, right? So the 3V is the positive and G, that is the ground negative, right? So now this positive of the sensor need to connect to the positive, negative of the sensor need to connect to the negative, right? Positive and negative, right? Positive need to be connected positive, ground need to be connected to the ground, that is negative, right? So now I have given the power to the sensor, right? Whenever you are giving the power to the sensor, right? Whenever you are giving the sensor will on. So in my case, see, let's say I am taking this gas sensor, right? So now this blue color is my positive. Blue color wire I am connecting in the positive, and then the ash color wire I am going to connect in the negative, right? I am seeing the positive, I am going to connect the positive in positive and negative in the negative. So whenever you are connected a sensor, see here the power light is coming. If the sensor is having the power light, whenever you have connected the power, then the power light it will be indicating, right? Can you get my point? So now you have given the power to the sensor, right? Again, you need to get the data, no, right? So the data need to be connected to the data pin, right? So now, since this is an analog sensor, right? To which pin I need to connect? I need to connect to the analog pin. So analog pin in the node MCU where it is, see here, A0. That is the only analog pin which is available in the node MCU. So here you can see D0, D1, D2, D3. These are all digital pins, right? So the only analog pin that is available in the node MCU is A0, right? So now you need to connect to the A0. Now the data of the sensor is connected to A0. Students, can you able to tell? Now this A0 pin is an input pin or output pin? Can anyone able to tell? You can able to you can post your answer in the chat box, right? You can post your answer in the chat box. Whether this A0, whether this A0 is an input pin or output pin. Anyone can answer. Okay, right. Good. So I'm getting answers from many students. Good, right? I appreciate your active participation in the workshop, right? So it is an input. You need to declare this pin as an input. Why? We are going to get the input. See, for sensor, it is giving. It is an output for sensor. It is the output for sensor, right? But for this board, it is an input. Sensor is giving some input to the board. The output of the sensor is connected to the input of the processor board, right? So always while you are programming, you need to code in the point of microprocessor only, not in the point of sensors. If you see in the point of sensors, that is an output. If you see in the point of processor board, it is an input, right? So you need to initialize this A0 as an input pin, right? So now we will see the code, right? So how to get the value from the sensor and print the value, right? So where we are going to print? In the serial monitor, right? Whatever the value that the sensor is sensing, that will be printed in the serial monitor, right? So we will see the programming, we will see the program code. All right. Good. So now int analog pin, right? So int analog pin. What I am doing here, I am creating a variable analog pin. So this is user defined. Whatever the name you want, you can give user defined, right? Again, a naught. A naught. What is a naught here? The pin name, right? So this is not user defined. You need to give the exact keyword. A0 is the keyword which is used for analog pin 0, right? So which is the pin which is here in the left hand side corner of the board. So that is A0. Now what I am doing, I have created a variable called analog pin and I am assigned the A0 to that variable. So wherever I am using this analog pin variable, which indicates the pin A0. Can you get my point? Again, I have created another one variable called VAL, value, right? Value, and I have initialized that variable as 0, right? And initialized this value variable for this value is 0, right? So these are the two declarations, right? Variable initializations. I have created a variable and I have assigned some values, right? Again, here you can see the setup part, serial.begin. Why we are using serial.begin? To see the output in the serial monitor. Okay, so I have used the baud rate as 9600. Again, pin mode. See here, pin mode. What is the pin I am going to use? A0. The name which I have given to A0 is analog pin, right? So pin mode, analog pin, input. I am going to use the analog pin as an input pin. So now I have initialized the pin. Right now the setup part is over. Right now the setup part is over. Now what I'm going to do, I'm going to read the value from the sensor. For reading the value from the sensor, the function that we are going to use is analog read, right? So inside this, you need to give the pin name. See, this is the parameter. See, this is the function. How many parameters we are using? 2 parameters, pin name and status. This is the function, right? How many parameters here we are using? Only one parameter. What is that? The pin name. So whatever the function is returning, that will be assigned here. Value is equal to, for the value I am assigning this one, right? Again, I am printing that value, serial.println val. Whatever it is coming here, it will be printed. Right? So what I am doing here, I am connecting a sensor, I am doing analog read, I am printing the value in the serial monitor, right? So now let us execute and see the program. Okay, see here, error is throwing. See, can you able to see? When I am compiling, here it is showing the error. That is, it requires the semicolon. So you need to give the semicolon. So like this, if there is any error, here it is status. You can able to see, right? So now no errors. I have cleared the error. Then it is the code is uploading, right? The code is uploaded to the hardware. So now the code is uploaded completely. It is uploaded. So after this, what I'm going to open the serial monitor. See, the serial monitor, can you able to see the values? Continuously it is running, right? Continuously it is running. Why it is continuously running? So inside the program, I didn't give any delay, right? So it is continuously. This is called active sensor. Continuously it will sense and then it will throw the values, right? So now I am blowing to the sensor. Can you able to see there is a difference? Can you able to see the difference, right? So whenever you are continuously it will sense, that is the active sensor, right? So now what I did, I have powered the sensor, I have connected the data to the A0, right? And then the value, right? So now the objective, right? I want to sense the data, or I want to print the data only 1 second once or 2 second once. What you need to do here, you need to add the delay. Delay. If 2 seconds means how much you need to give? 2000. Once it is uploaded, so instead of continuously coming, the value how it will come? For 2 seconds once, one value will come. Right? Uploaded. So now clearly see one value is printed after 2 seconds delay, other value. See each and every 2 seconds the value can be printed. Right? Can you able to see the difference? Right? Whenever the value is hence the value can be given. Right? Any doubt in this? Any doubt in the analog reading? Analog. See why we are giving here analog read. See the value which we are getting here, it is an analog value, right? So here it is. If you want digital value, digital means what? 0 and 1, right? Few sensors, you need to get the digital. See, for example, if you want to open a door whenever a person is coming, so there you can use digital read. Why? If the person is coming, then it is 1. If the person is not coming, then it is 0. If it is 1, open the door. If it is 0, close the door. Right? So there you can use digital read. Right? See, instead, if you are using temperature sensor, so there you need to get the temperature value 92 degrees Celsius, 10 degree Fahrenheit, or 20 degrees Celsius, 25 degrees Celsius. Like that, you need to get the value, decimal value. On that case, we need to use this analog read, right? So now, see here, students, instead of using analog pin, right? Instead of using analog pin, what we can directly do. See now, I am deleting this tool, and then here itself, right? Here itself, in pin mode itself, you can give A0, right? Again, here analog read A0, right? Again, I am taking this, I am deleting this variable. Again, here inside itself, that is serial.println itself, I am giving this function. See here, already serial.println is a function. Inside the parameter, I am calling another one function. So whatever this analog read function is returning, the value which is returned by this analog function, that will be given as an input to the serial println, and then that value is printed. Right? So the same program can be written like this also. Right? So instead of giving the variable and then calling, you can give the directly the pin numbers also. Right? Can you able to get my point? Right. Any doubt in this program? Any doubt in this gas sensor, that is analog values, how to connect, how to code? Right. The same program, right? The same program I have extended with the condition. Right? So here I have used the conditional statements. So now, what is the condition I have used here? See now, I have taken the value of variable. If the value is less than 10, right? If the value is less than 10, digital write LED built-in high. That is, If the value is less than 10, then the LED need to on. If the value is greater than, then it will be right. So here you can get the condition, right? The same way for whatever the sensor. See, if you want to measure the temperature sensor, right? The room temperature, right? If the temperature goes beyond this, see if the temperature goes 30 degree, then turn on the AC. If the temperature goes 18 degree, turn on the heater, right? So you are getting the value from the sensor. Again, you are checking the condition for that. As like other programming languages, here also you are using the conditional statements, right? So if and then the condition, then inside the condition statements, right? So if this condition is true, right, then the light will on, or else the light will off, right? Any doubt in this program? Right? Any doubt in this? Right. The next program that we are going to see is, now we have seen the example of which sensor, active or passive? Active sensor, right? Now we are going to give one example of passive sensor, right? For passive sensor, one example is ultrasonic sensor, right? So now why we are using this ultrasonic sensor? So this ultrasonic sensor mainly used to identify the distance between the sensor and the object, right? So now let's say this is the sensor. So I want to identify the distance between this object and this sensor. How long the distance, right? For that you can use this ultrasonic sensor. See here, I am not sensing whether the object is present or not. If you want to measure the object is present or not, you can go for PIR sensor or IR sensor, right? If the object is present or not. So here we are going to check the distance between the object and the sensor, right? So what is the distance between the object and the sensor? That is the objective of this sensor, right? So how it is work? See now, we will see the connection part. So there in that sensor, how many pins we have seen? 3 pins, right? So 2 are power pin and the other one is data pin. Whereas here you can able to see 4 pins, right? Again in this 4 pins, 2 are power pins, right? It is mandatory. Whatever may be the sensor, 2 pins it will be the power pin. What are the 2 power pins? Positive and negative, VCC and ground, right? Again, now the VCC is connected with the VCC, right? Again, the ground is connected to the ground. Any doubt in this connection? Right? So now what I did, I have given the power. I have given the power to the ultrasonic sensor. Right? Again, 2 data pins. One is for transmitter and another one is for receiver. Right? One is the transmitter and another one is the receiver. So now, these 2 data pins, how you need to declare? Whether you need to declare it as an input pin or whether it needs to declare as an output pin. So there we have declared it as an input pin because the sensor is giving the input. So here, input or output? Yes. You need to use both input and output. So I said 2 data pins, right? So one is input pin, the other one is output pin. So trigger and echo. The trigger is the pin which is going to trigger the ultrasonic waves, right? So whenever the ultrasonic waves are triggered, if the object is there, the triggered ultrasonic wave will reflect and come, right? It will reflect and come. So that reflected ultrasonic wave will be received by this echo pin. So the trigger pin need to be connected as an input and then it will be, right? So that is how you need to declare. So now in the connection part, I am using D2 and D3. See, there I have used analog pin A0. So here I am using digital pin. So in this circuit, I am connecting this to D2 and D3, right? So 2 data pins I have connected to D2 and D3 simultaneously, and then I have powered the sensor, positive and negative, right? So now we will see the coding. See here, I have created two variables, trigger pin, and I have assigned the pin D2, again echo pin D3. So these are the variables I have created and assigned the pin D2 and D3. Again here you can see trigger pin as an output, echo pin as an input, right? So this is not in the perspective, it is not in the perspective of, it is not in the perspective of what? Sensor. It is in the perspective of board. For the board, trigger pin is an output. For the board, echo pin is an input, right? So that is all about setup part, right? So now the setup part is over. Right now the setup part is over. So again, now the coding part inside the loop, right? What I am giving digital write echo pin low, digital write trigger pin low. Initially, I am setting these two pins as low, right? Initially, I am making those two pins as low. That is, initially I am turning off, right? Initially, I am turning off those two pins. Right. So these two pins, that is, I am first time turning off. Again, see here, delay in microseconds. See, if you are using delay pin alone, if you are using delay pin alone, the delay will be in milliseconds. So here for this program, especially for this program, the delay that we need is in microseconds. So I am using the function called microseconds, 2 seconds. See, now what I am going to do, I am going to trigger the ultrasonic wave for 2 microseconds, right? 2 microseconds, and then I'm going to wait, right? I have triggered the ultrasonic wave. I'm waiting. If I am receiving the ultrasonic wave in the receiver, sent time and received time. Based on the sent time and received time, I am going to identify the distance between the sensor and the object. If the object is there, then it will come back, reflect and come back. If the object is closer, then the reflect time will be less. If the object is longer, then the reflect time will be high, right? So now you don't need to, right? You don't need to calculate anything, right? Already everything the calculation will be there. See here, using this ultrasonic wave, how to calculate the distance, right? So these two lines, that is the duration and distance, which indicates this calculation part. You don't need to worry about the calculation part, right? So this calculations and all, it will be available in the sensor manual itself, right? So just you can follow the calculation methods. Using this calculation methods, you can get the distance, right? So whatever the distance that you are getting here, so that will be the distance between the object and the sensor. Okay, can you get my point? So now, so whatever the distance between these two, that will be printed, right? So let us execute this and then we will see.
அப்படி நானே போன் அப்படி நானே கூட நான் பின்னாடி
Yes. So I'm uploading the code. Then you will see here the ultrasonic sensor is throwing the value that is out of range. Out of range in the sense objects are very closer to this ultrasonic sensor. So that is what the condition which we are giving. If the distance is less than 200, then it will be, that is 2 to 200, then it will be out of range. So then if the distance is high, then it will give the distance value. Whatever the distance value, it will be giving in the centimeters, right? It is going to give the values in the centimeters. So the value which is, that is the distance between the sensor, the distance between the sensor and then the object that is reflected, right? The object that is reflected is going to be coming in the values that is greater than 200. If the value is greater than 200, then the distance will come, right? Right. Can you able to see the distance now? So the distance, when you are increasing, then automatically it will show the distance value. Whatever the value that you are giving, it will be showing, right? So if you are removing, right, if I am removing this condition, right, if I am removing this condition simply, if I am printing the distance alone, right? So if I am printing the distance alone, then the distance value alone, it will be printed. So if I am removing the condition, I am uploading, right? I am removing the condition and I am uploading the code. So once it is uploaded, then it won't give out of range. Only the value it will give. So here why we are giving the condition in the sense. So sometimes when we are using this sensor, right, the object will be too closer or that object will be not detected. At that time, it will be to give some appropriate values. We are using the out of range. So here you cannot able to see now this out of range is not coming. Whenever the object, right, whenever it is detecting that sensor's value, then only it is going to print the value. Or else what it will do, it won't print any of the value in the serial monitor. Right? So that is the major difference between the code which I have uploaded before, that is with the condition and without the condition. With this, we will wind up for today's session. Students, do you have any doubt till now? So keep in mind, so tomorrow what you need to do, you need to code for 3 LEDs, right? You need to code for 3 LEDs. For the 3 LED, the code need to be uploaded. Okay. And then tomorrow what we will do, we will try to connect one device, and then from the remote device, we are going to control that device. So today we have seen the sensor connectivity, right? Sensor connectivity demo. Then tomorrow we will see the remaining things, that is connectivity. And then tomorrow, if possible, you people can create one account in ThinkSpeak, right? So tomorrow we will see that cloud connectivity also. Okay. So with this we will end up. Thank you.
Yes, Darwin, shall we wind up?
Yes, sir. Yes, sir. We can wind up, sir. Thank you, sir.
Thank you, participants. Thank you so much. Don't forget to give the feedback. So the feedback link is already posted in the chat box. I hope you already found the feedback and started filling it up. Okay, so don't forget this feedback form. And with this one, we are winding up. Tomorrow, exactly 4:30, we will meet again for the final day of this training program. Thank you once again. Thank you so much. Goodbye.